In our previous discussion, we have discussed about flame photometer, right? How to estimate or determine the concentration of particular substance in given solution using flame photometer. Today, we are going to determine atomic absorption spectroscopy, how to determine the given constant present in the given solution using atomic absorption spectroscopy. So here, in previous experiment, what used to do is to expose the solution to the substance to the flame. So when here also we're going to expose the substance to the flame. So only difference here is there we used to measure the amount of light emitted, but here we're going to measure amount of the light absorbed. So there we used to take readings of the amount of light emission. Okay, but here amount of light which is absorbed. So the basic principle is when a solution having a mixture of metallic species is introduced into the flame, the what will happen? The solvent will get evaporated. So metallic leaving behind the metallic species. So some of the metal atoms can be raised into, as usually you know that metal atoms will be raised into higher energy level and it will emit the radiation of metal phenomena that will be used in the flame photometer. When the light is coming back from excited level to the ground level, it emits some amount of the light. So how much amount of light it is emitted, if it is in the visible region, we are going to measure that. So here what happens, a large amount of atoms remain in non-emitting ground state. So it will not emit at all. So it will remain in the ground state. So these ground state atoms of a particular element are receptive. It will absorb some amount of light radiation, okay, in at particular wavelength. So how much amount of light is absorbed we're going to determine. So in atomic absorption spectroscopy, the amount of light absorbed is determined because the absorption is directly proportional to the concentration of the element. So there where what will happen, the amount of light, metal is excited, it is coming back, right? But here majority of the elements will be in the ground state, and that ground state metal will absorb the what, the light, so at particular wavelength. So the amount of metal absorbed is directly proportional to the concentration of the metal present. By knowing the amount of light absorbed, we can determine the concentration of the substance. So let us see how the experiment is carried out over here. So in the atomic absorption spectroscopy, the amount of light is absorbed determined because the absorption is directly proportional to concentration of the element present in the sample. So as I told you earlier, so these are the, a large amount of metal atoms remain in the ground state, okay, in non-emitting ground state. So these ground state atoms of particular element are receptive of light radiation of their own specific resonance or wavelength. So in this way, when light of wavelength passes through a flame, a part of light will be absorbed, and this absorption is proportional to the intensity of atoms in the flame. So this forms the basics of your atomic absorption spectroscopy. So let us see the instrumentation. What are the apparatus present here? It contains radiant source, so light source. So generally a hydrogen lamp is used as a continuous source of radiation. So next it contains atomizer. So generally generally burners are used to break the liquid sample into droplets, where the droplets are then evaporated. The droplets are then evaporated and sample element is left as residue. The residue is then decomposed by flame. Okay, so next you have a monochromatizer. So monochromatizer is nothing but you have is light, right? So when light enters into, you have single light. So sunlight is white light composed of wavelength from some 400 to 700, but we want a single light of one wavelength. So 620 means you're supposed to adjust the filter. When a light passes through the monochroma filter, so visible light passes, but light coming is of only one light. So generally monochromators or graters are prisms. Okay, so next you have lenses and slits. So what are lenses and slits? So filters or slits are used to isolate the spectral line if element has a simple line spectrum. So filters in photometers are used to determine potassium, sodium, calcium, magnesium, etc. present in the sample. So next we have detectors. So detectors generally means that photo multipliers are used as detectors. So photo multipliers are used as detectors in atomic absorption spectrometers. In some instruments, two filters and two detectors are used to compensate the fluctuations in the sources. So these are the apparatus used in the atomic absorption spectroscopy. Let us see how to perform the experiment here. So this I can see over the atomic absorption spectroscopy is the, so this is the halogen cathode lamp from where light is produced. This is flame. So here the sample is produced over here. So it will be mixed over here. It will go here. It will be sprinkled over here. This is slit or a grater. Here the monochromatizer, and this is detector. From here it is connected to the indicator device. The reading will be detected over here. So how to perform the experiment? So first of all, the meter will be adjusted to 0. So whether it is colorimetric estimation or flame photometric estimation, the initial reading will be blank reading, that is 0 reading. So that is 100%. 0 absorbance means 100% transmittance will be present. So blank is sprayed. Blank is water will be sprayed. It will have 100% absorbance. So then there is a comparative method. So there is a comparative method going to prepare a standard solutions of 2, 4, 6, 8 ppm are used to make a calibrator curve. So now the solution to be investigated is introduced. A certain part of light is absorbed, resulting in decrease of intensity of light. So now you get all readings are noted down. Going to plot a graph of concentration of one particular metal, maybe copper or anything, and absorption. So you get the calibration curve. So this calibration curve you might have seen, it will be, you have seen in flame photometer, you have seen in colorimeter, right? There is some unknown solution. So you know the absorption, but you don't know the concentration. So absorption, we're going to point out here, we're going to draw a dotted line until it touches the curve. Once it touches the curve, we're going to drop a perpendicular to the x-axis. Whatever you get here, that is the concentration of the particular constituent. So what are the advantages? What are the applications? So the applications of atomic absorption spectroscopy is it is mainly used in quantitative analysis. Okay. So disadvantages. So this technique has not proved very successful for the estimations of vanadium, silicon, molybdenum, titanium, aluminum, because these elements give oxides in flame. So what will happen? You will get aluminum oxide, vanadium oxide. So because of this, you will not get exact concentration or accurate results. So other than this, what will happen in an aqueous solution, we have anion effect. So you will not get a proper signal. So a separate lamp is to be used for each and every element. So this is also a greater disadvantage. So because of this, we are not going to, these are the major drawbacks and is not successful. So instead of this, we are going to use flame photometric or colorimetric method to estimate the given samples. Okay. Thank you.